Seconds to figure out setting up my screen here, and then we can dive in. All right. Y'all can let me know when this is visible here. Perfect. So yeah, this talk is a bit of a kickoff, an intro to ERC 6551 and its sister improvement proposal, SNIP-14 on the Starknet side. We're going to talk a little bit about what this is, what a tokenbound account is, talk a little bit about the why behind these proposals and what they're attempting to accomplish. I won't talk too much about the how to use it in your projects, because I think there's a couple of other really good talks later on that will be going into the details of that. But for now, this will be a bit of an overview. So my name is Jayden. I'm the CTO at a company called Future Primitive, and I'm also one of the co-authors of the 6551 proposal. And if you want to find me, that's my Twitter handle. At Future Primitive, we love NFTs, especially experimental NFTs. We've been building NFTs for a long time. One of our co-founders worked on CryptoKitties, and then that became Dapper Labs, and so did Cheese Wizards and NBA Top Shot and a lot of early NFT projects. And since then, we've launched a bunch of just kind of weird, fun, experimental NFTs because we really do think that NFTs as a medium, NFTs as a new type of file format on the internet, NFTs as just kind of this really interesting thing are compelling. One of the things that's really shaped how we think about NFTs is this idea of cryptocurrency as the internet's money layer. So, before we had cryptocurrency, the internet was just lacking money that was designed the way the internet was designed, right? The internet is designed to be peer-to-peer, it's designed to be digital, it's designed for everybody to have access to it. But we didn't really have money that was designed that same way until cryptocurrency came along. With cryptocurrency, we now have money that's built native to the internet, money that's designed the way the internet is designed, right? It's peer-to-peer, it's electronic, anybody can use it. And so we have these really good systems now for representing things like dollar bills on the internet. But what about objects? What about all the other things you use in your life that aren't a dollar bill, that aren't just interchangeable, but are unique and have utility? The things that you interact with on a daily basis, how do we represent those things on the internet? Now, NFTs were a good start to that, right? With ERC 721, we had the concept of a unique digital object that you can own and transfer and buy and sell. And that was a really good start to creating an object layer for the internet, a native way for objects, unique things to be represented on the internet. Tokenbound Accounts attempts to take that all the way and give all of the complexity and possibilities to NFTs that are necessary for NFTs to be the object layer of the internet that was just missing from previous standards. So we really want NFTs to be the object layer of the internet. And we're trying to build towards that. And so that's why we introduced 6551 and this concept of a token-bound account. This simple idea behind this is that every NFT that's ever existed in the past or ever will exist in the future has its own wallet, its own unique wallet address. And that means that every NFT is capable of a whole new set of things that it couldn't do before. It means NFTs can own assets. Your NFT can own cryptocurrencies, or it can own other NFTs. Your NFT can really own anything that exists on chain. And it can have relationships with those things, right? Not just an ownership relationship, but any kind of relationship you can express on chain. NFTs can now have that because they have a wallet. Also means NFTs can do things. They can take actions on chain, they can execute transactions. It means your NFT can be a user of any experience that exists on chain. It also means that NFTs have their own history. It means that as you use your NFT over time, your NFT changes. You have all of this rich history of all the things your NFT has done. It's just like an object in the real world that the more you use it, the more it changes. NFTs now have that same property as well. And so adding a wallet to every NFT really opens up a lot of new things you can build with NFTs. And that's the core idea behind tokenbound accounts. And when we launched this a little while ago, every NFT that's ever existed and every NFT that will exist all of a sudden went from just being a thing you could buy and sell and trade, just this kind of static asset, to being this dynamic object. When you couple an asset with an account, that gives rise to a lot of new cool things. It means that NFTs have identity. It means they have, just like your wallet is your user identity in Ethereum applications, your NFT has its own identity now. Just like your wallet can hold data about you as an Ethereum user, so can your NFT. Your NFT also gets some new features that aren't found in normal wallets, like different ways of authenticating who is able to use that NFT. So 6551 adds all these different layers to NFTs and lets them really be the object layer of the internet. And importantly, NFTs didn't have to change for this to be a thing. You don't have to migrate your old NFTs or add new functionality. Every NFT gets this out of the box. And so far there's been a lot of adoption of this idea of token-bound accounts. We've got a little bit over 250,000 accounts deployed on the main Ethereum chains. We've got a lot of NFTs held inside token-bound accounts. The developer community has been growing, and you can see a bunch of logos at the bottom of people who are building with token-bound accounts. So as you're working on projects that are building with token-bound accounts during this hackathon, you're in really good company. Now, sometimes it's a lot easier to show rather than tell. And so I've talked a little bit about why NFTs should have wallets and what you can do with a token-bound account, but it's probably a little bit easier to show you. So I'm going to show you the ERC-6551 Explorer. It's at tokenbound.org. This works for the main Ethereum chains. I know on the Starknet side, there's a Starknet version of this that you can check out as well. But I'll give you a quick demo of what a token-bound account is, how it works, and show you some cool things about it. So I go over here. This is an NFT I own. This is an NFT called the Sapiens. It's an NFT project we launched and really was kind of the genesis for this idea behind token-bound accounts, because we wanted to make an NFT where the clothing on it and the features of this NFT were equipable, where you could swap the t-shirt or you could swap the background. And so this is my Sapien right here. And you can see it's got a unique wallet address right here. This unique wallet address is its token-bound account. And this wallet owns 3 NFTs. It owns this coffee bean and these 2 pieces of gear. If I ever transfer this NFT, this Sapiens NFT, to someone else, they would get everything that's in the wallet, all 3 of these NFTs, and it owns a little bit of ETH as well. So the account always goes with the NFT. When you own an NFT, you are authorized to use its token-bound account for as long as you're the owner, but as soon as that ownership transfers, everything inside the wallet goes with it. So you can kind of think of it like a bundle of sorts. Now, this NFT can own things. It can be this kind of bundle of other things. That's really cool, and that's something you couldn't really do with NFTs before. But this is really just scratching the surface of what you can do with NFT. Because this is just a wallet like any other wallet, I can use this wallet to connect to any dApp that supports wallets, which is really any dApp out there. So the use cases for what your NFT can do really becomes the use cases of Ethereum as a whole. So if I go over to OpenSea here, I just move this little thing out of the way. If I want to use OpenSea as my NFT, all I need to do is click login, grab the Wallet Connect URI, head back to the token-bound site, and connect. And now I've just logged into OpenSea as my wallet. And you'll see here that it's prompting me to sign a message. Now, this is prompting me to sign a message using the wallet that owns this NFT. When I sign this message, I'm actually signing on behalf of my NFT. So from OpenSea's perspective, it's my NFT doing the signing, not my personal wallet doing the signing. So if I sign that message to sign in, you'll see when we go to my profile that I'm logged in as my NFT's wallet. You can see my NFTs, the NFTs it owns are showed up here. You can see the ETH it owns are shown here. And now I can just use OpenSea as my NFT. Every action I do on OpenSea is coming from my NFT's account, not just from my personal wallet. And so if I wanted to go in here and say I wanted to sell this NFT or list it for sale, I could come in here and say I want to list this for 0.1, and I hit complete listing. And what's going to happen is my personal wallet is going to pop up and prompt me to take this action on behalf of my NFT. And so if I was to hit confirm, this would cause my NFT to go and list one of the NFTs it owns for sale on OpenSea. What this means is that every application, every dApp that supports wallets supports NFTs now. It supports NFTs as users. It means that your NFT can take advantage of all of the things that have been built for cryptocurrency users, all of the cool use cases, the cool experiences, the cool things you can do in Ethereum are now something that your NFT can do as well, which opens up a lot of cool possibilities. Now I'll talk a little bit about how this works under the hood, the way the contracts are structured, and then can open it up for any kind of questions you guys have. So with tokenbound accounts, in this little diagram here, you can see two NFT contracts and two NFTs. We have NFT number 123 and NFT number 456, and they're in separate NFT collections. We've also got a user wallet. This wallet owns NFT number 456. And if you own NFTs, this is probably pretty familiar. Your wallet owns NFT. What 6551 and SNIP-14 do are they introduce a registry contract. This registry contract is responsible for assigning a unique wallet address to every NFT. So as soon as this registry comes into existence, every NFT now has a wallet address reserved for it. That means every NFT now has the ability to own assets and do things because it's got that unique wallet address. And the registry handles mapping the NFTs themselves to the wallet addresses they own. And it also handles creating those wallets because these are smart contract wallets. They need to be created. So the registry takes care of that as well. This is kind of the thing that works behind the scenes to make NFTs able to have accounts, which makes them able to do all the things we've discussed. It's all powered by this registry contract. Now, each of these accounts is actually a proxy contract. That means that it proxies to an implementation contract. And that means that you can have different tokenbound accounts that do different things. The core invariant, the core thing that is true for all tokenbound accounts that follow the standard is that it's an NFT that owns the account. This account, see here, is owned by token number 456. And because token number 456 is owned by this user account, that means that this user is able to control account C. It's able to use account C to do things. And this account is powered by an implementation. So what happens when this user does things is determined by the implementation the account uses. This also means that NFTs can have more than one account. Just like you as an Ethereum user might have multiple wallets, might have a hot wallet and a cold wallet or wallets for different things. Your NFT can have multiple wallets too, multiple wallets for different things. And because there are different implementations that change the logic of those accounts, you can have different wallets for different things or different wallets for different applications. So this is how it works under the hood. The registry is what powers all of this and is what's defined primarily in the EIP 6551 and SNIP-14 proposals. Now, the registry is a really, really simple contract. This is the Ethereum version. There's a very similar version of this on Starknet. It has two functions. The first is called create account. You pass in these arguments, the implementation address of the contract that you're proxying to, the details of the NFT you want to tie this account to. So that's the chain ID, the token contract, and the token ID of that NFT. And then a salt value, which is just an extra source of data you can use to change the tokenbound account address. If you call create account, it will deploy the contract at the tokenbound account address. If you just want to get the address of the account without doing the deployment, you can call the account function with the same arguments. And this is very similar to how it works on Starknet. There's also a minimal account interface that all tokenbound accounts deployed from the registry will have. The first is it must be able to receive assets, so the native asset of the chain. The second function called token is what, because all tokenbound accounts are owned by an NFT, this function token will give you back the details of which NFT owns the account. The chain ID, token contract, and token ID kind of replaces an owner method because tokenbound accounts aren't owned by wallets, they're owned by NFTs. And then the NFT determines who's able to use the tokenbound account. There's also a state function, and this is really useful for marketplace integrations. Anytime you do something with your tokenbound account, the value of state will change over time. And so you can determine if an account has been used between 2 points in time. Then finally, there's an isValid_Signer function. And what this does is this determines for a given wallet address, whether it's able to use this account. Because again, accounts are owned by tokens, by NFTs. And so based on ownership of that NFT, is a given user able to do something on the account? There's also an executable function. This is a little bit different in Starknet because of the inbuilt account abstraction. But you can call the execute function on a tokenbound account to do transactions from the account. So when you saw me do the demo with OpenSea earlier and I could have listed my NFT, really what that was doing was calling this execute function on the tokenbound account and having it go forward and do the action. when we were designing 6551, we really wanted to make sure that a couple of design criteria were met. We were building a project with NFTs. We wanted to give NFTs this extra kind of feature set, this extra set of things you can do with an NFT. And there's a couple things we wanted to be true. And so 6551 accomplishes all of these. First, we wanted to make sure it worked with every NFT, not just new NFTs, not just NFTs that adopt this standard, but work with all existing NFTs, past, present, and future. We also wanted to make sure it worked with any kind of tokens in terms of the things you could own in a wallet. We want to make sure an NFT could own ERC20s or ERC1155s or other NFTs, or if some new token standard was created in the future, this would be able to just adapt to that because token-bound accounts are just
Whose sketch
wallets.
is this?
So if someone creates a
Oh,
new token standard in the future, token-bound accounts will just be able to adapt and own those new types of tokens. We also wanted to make sure there was no wrapping contracts. You didn't have to wrap your NFT to get some extra functionality. This is a big one. We really wanted to make sure that token-bound accounts and this whole new feature set for NFTs worked with existing platforms, things like OpenSea or MetaMask or Etherscan. The things that you use every day as an Ethereum user, you shouldn't need to have special, custom things built for NFTs to be compatible with them. It should just work out of the box. And so you saw how when I logged in with my token-bound account to OpenSea earlier, it just pulled in all the NFTs my NFT owned, it pulled in ETH it owned, because OpenSea doesn't need to know that you're an NFT. It doesn't need to know that you're using it as a token-bound account. Things just work out of the box. Token-bound accounts become the bridge between NFTs and the rest of the Ethereum world. And we wanted to make sure it was fully decentralized, it's full self-custody wallets. And so 6551 accomplishes all of these things. Now, you might be thinking, this is really awesome. This is great. I'm at a token-bound hackathon. I can't wait to get started on this. What's the downside? Or what are the kind of open problems here that are still being worked on? A big one that'll especially come up with all of the cool stuff you guys are building on Starknet is multi-chain support. How do we take NFTs and make them, apply this new paradigm of NFTs having wallets? How do we make that true on every Ethereum chain? How do we make that true on every, cryptocurrency VM, so virtual machine, of which the Cairo VM Starknet is one of them. How do we just take this idea that NFTs can do things and own things and apply it everywhere? And I think the folks who are working on SNIP-14 have done a really great job of this, of taking this concept and applying it to a new type of VM. But where else can this go, right? How can we add better and more cohesive support for other VMs? How do we make sure that this is fluid across the whole token-bound ecosystem? One of the things that's really interesting on the Ethereum side of this is that because the registry address is deployed to the same address on every chain, that means your NFT owns its wallet on every chain at once. So if your NFT has wallet address 0x123, it'll also own that wallet on Polygon and on Optimism and on any other EVM compatible chain, meaning you don't need to move your NFT between chains just to use it in applications. If you want to use your NFT in an application, you can just use its token-bound account without bridging the whole NFT itself. Now, this works really well for EVM chains, but how do we expand this model to support things like Starknet? That's a kind of an open question at this point that I know some folks are working on solving. Another one is just marketplaces in general and trying to combat against this being used as a tool for marketplace fraud. Pretty much all NFT marketplaces were designed around the concept of stateless NFTs. NFTs that don't change state over time. They're just, a single static asset that sits in your wallet. And so marketplaces are really great at facilitating transactions of stateless NFTs. But token-bound accounts take all NFTs that were previously stateless and make them stateful. It means they change over time. You can put assets into the wallet, you can take assets out. That's a change in state over time. And so marketplaces aren't really well equipped to handle this. They don't know that the account changes state. And so there's not really a way that they can prevent someone from, say, putting some valuable tokens inside of an NFT, but then taking them out just before they accept an offer on the NFT that the seller or the buyer assumed would come with those valuable tokens. And so this is a really interesting area. How do we build new types of marketplaces that are aware of token-bound accounts and are aware that NFTs change states? How do we build integrations into existing marketplaces so that existing marketplaces can use this paradigm? There's already some great work being done on this. The primary way of handling this is with that state function on the account interface. And so we're working on some integrations there, but really curious to see some of the explorations that might come out of this hackathon around this problem of marketplace integration for token-bound accounts. And then finally, this isn't really an open problem per se, but more something to be aware of when you're building token-bound accounts. And this is the concept of ownership cycles. So if an NFT can own another NFT, what happens when an NFT owns itself? Or if an NFT owns another NFT and this NFT owns this NFT? This is called an ownership cycle. Anytime you create a loop of ownership where an NFT functionally owns itself, that really means that nobody owns any of these NFTs. It's essentially like a burn mechanic, right? If you introduce a cycle of ownership, now none of those NFTs have an owner, so none of their token-bound accounts can be used. This was intentionally left in there because it's kind of an equivalent to the burn mechanic in NFT context, right? If you own an NFT, you have the right to destroy it. Similarly, with a token-bound account, if you own a set of token-bound accounts, you do have the right to destroy it. But this is something to be careful of in your applications if you're building with them, or potentially something that you can use as a really interesting mechanic in the NFT applications you build. What if you built a type of NFT that did something special whenever an ownership cycle was introduced, or used this as kind of a burn mechanic in your project? So just something to be aware of. That's pretty much it from my end. If you're curious about how this works on the Ethereum side, tokenbound.org is the place to go for all of that information. Docs.tokenbound.org will show you the Ethereum side of this with all of the contract addresses and SDK documentation. On the Starknet side, there's a whole other set of things, and I'm sure there'll be some great talks later on that will show you all of the nitty-gritty of interacting with those. But yeah, that's tokenbound accounts in a nutshell. Thank you all for having me, and happy to answer any questions anyone has.
Thank you so much, Jayden, for that insightful session. So, guys, if you have any questions, you can ask now before we call it a day. Okay, I think someone is asking a question.
Yeah, this is a good question. So the question is, can we only have one implementation, one TBA implementation per proxy? And the answer is yes. So a proxy will point at one implementation of a contract. On the Ethereum side, this uses ERC 1167 proxies, which are static. So the implementation address you pass to that create account call is static. It can't change over time, and there's only one implementation address. You can get around this if you want. If you want to have an upgradable implementation, or if you want to have an implementation that has kind of like multiple areas that it pulls its logic from, you can do that by pointing the implementation address at an upgradable proxy or a diamond proxy or whatever kind of smart contract structure you want to have for your token-bound account. And that will essentially take it from a static proxy into a dynamic proxy that you have more control of. That's a really good question.
Okay. Thank you so much for the answer. Any other question from the audience? Any other question? You can also unmute your mic and ask your question. Oh, sure. You have access to the slides and the recording after the workshop. Any other question? I think if there's no other question, okay.
This is what there's
All
another
right.
one. So
There's
can you
another
have multiple TBAs within one TBA? This is a good question. So it's like, if you have an NFT, can this NFT own multiple NFTs? And the answer is yes. You can own as many NFTs as you want per wallet. But that introduces a really interesting scenario because this NFT now owns multiple NFTs, and each of those NFTs can own multiple NFTs. And each of those multiple NFTs can own multiple NFTs. And so, yeah, you can have multiple token-bound accounts within a single token-bound account because you can nest them. So you can have an NFT that owns an NFT that owns an NFT that owns an NFT. And you can build some really interesting things with that. We refer to this as a token graph because it's kind of like representing a graph data structure on chain. And so you can build some really cool things with this. And a token-bound account can definitely have multiple other token-bound accounts. Then you just transfer more NFTs into that token-bound account. Another good question. It's still a draft ERC on the EIP website. Is there an ETA on final form.erc? Any consequences of it still being draft on ecosystem implementation and its usability? Really good question. So yeah, it is still, I believe it's in review right now. And so it's one step after draft. But yeah, it hasn't been finalized. And the reason for that is that once you finalize an EIP, you can't change it. There's no additional changes that could be made. And so there's still a couple of things, like I was mentioning in the open problem section, there's still a couple of things we really want to nail down and make sure are super solid before we move to finalization on it. The biggest two being making sure cross-chain support works really well and making sure marketplace integrations work really well. And so both of those are largely dependent on the folks who are building those ecosystems. So building some really good marketplace integrations is going to mean integrating with marketplaces and working with those marketplace teams, which is what we're doing right now. And so there's no timeline on finalization of it, but it is very stable right now. The contract interface for the accounts is likely not going to change in the future. It's already being used by a little over 250,000 token-bound accounts, and so it's still a little early. It's still something that hasn't been finalized, but it shouldn't prevent you from using it in your applications. Even if the standard changes, they're smart contracts that you own, right? They're fully self-custodial. So if you build your application on the current version of the contracts, that can never be taken away from you. So yeah, hopefully that answers the question. Another good one. Can TBA accounts also hold NFTs that are token bound too, and further nested down the line? Yeah, absolutely. Yeah, it's turtles all the way down. So you can have as deeply nested of a tree of token bound accounts as you want. And you can have you can build some really cool things with that mechanic of nested token bound accounts.
Yeah,
Awesome.
more questions. More questions, guys, before we close for the day. Any other question? Okay, so if there is no question in about 1 minute, I think we can just end the call, right?
Cool. Well, thank you so much for having me. This was a lot of fun, and can't wait to see some of the projects that you guys work on. I guess one last question here. Why on Starknet? And so this is an Ethereum standard primarily. 6551 is built largely for Ethereum chains. There's been some really great work by the folks behind SNIP-14 on porting that same thing to Starknet. I think it's a question of how do we take this idea of NFTs owning accounts and make sure it works everywhere, right? Make sure that Starknet isn't excluded from that really cool thing just because Starknet uses a bit of a different VM. So some great work has been done on that, and you'll be building some cool things on top of the SDKs and stuff that they've been working on there. So yeah, with that, I think we can close it off. Thanks, y'all.
Okay, so thank you so much, Jayden, for taking us on introduction to ERC 65551 today. It was really an insightful session. Thank you so much. And yeah, do enjoy the rest of your day. And guys, so from tomorrow, we're going to be having Anton session from tomorrow. Yes, so look forward to tomorrow's session and day 3 as well. So guys, I've come to the end of the workshop. Thank you for joining, and enjoy the rest of your day. Bye guys. Bye everyone. Yeah, the recording and the slides will be provided in the Starknet